Hello, welcome. Thank you for your patience as we start a little late today. So this is the Online Ethics Center's Fall 2022 webinar series called Bringing Ethics into the Conversation. My name is Caitlin Wylie. I'm an associate professor of science, technology, and society at the University of Virginia, where I teach engineering ethics and data ethics. So in case you don't know the Online Ethics Center, it is a digital repository for resources on teaching and learning about ethics in engineering and science. It also fosters a community of faculty, students, researchers, and other professionals who come together to discuss ethics. So please check out our website at onlineethics.org. The theme of our fall webinar series is sustainability and environmental justice. So I'm delighted to host our speaker today, Aaron Cook. Aaron is a licensed architect and project manager at Cold Climate Housing Research Center in Fairbanks, Alaska, which is part of the National Renewable Energy Lab. He manages the Sustainable Northern Communities Program, which designs and deploys emerging building technologies and approaches in the Arctic and the subarctic. He works with architects, builders, technicians, local leaders, and tribes to design, build, and monitor innovative buildings across the circumpolar north. He also works with me. So I get to collaborate with Aaron on a very fabulous study of infrastructure and climate interactions on the North Slope of Alaska. And I've learned so much from Aaron and his colleagues at CCHRC. So I'm delighted that he's here to tell us about his work. So after Aaron's talk, he's going to discuss his work with David Gutierrez, a Ph.D. student at the University of Virginia. And then we'll finish with questions from you. So if you want to ask a question, please type in the Q&A box at the bottom of your screen, and then I'll read it out to Aaron and David. I'm going to manage Aaron's slides. So this is going to be exciting. Aaron, come and join us, please.
Thanks, Caitlin. Good morning, everyone, or good afternoon, depending on where you are in the world. It's 9 a.m. here. My name is Aaron Cook, and like Caitlin said, I work at NREL's Cold Climate Housing Research Center, and I'm going to be shouting next slide through all this because we're having some technical issues. But next slide, please, Caitlin. My background is I was born and raised in Alaska, and this is the building where I went to high school. It's in Anchorage. It is called A.J. Diamond High School, and it was designed by a California firm. And you can see from the building that it's designed for a climate very different than ours. The campus I went to high school in was a cluster of disconnected buildings that eventually, through a crisis of conscience or a lawsuit, they connected with unheated breezeways. When you're in architecture school or engineering school, there's often a pedagogical decision about what type of architect or engineers the school wants to put out, whether it be modernists or classicists or sustainable architects. If you want to, next slide, please. If you want to create militantly regionalist architects, then all you really need to do is put them in a failed building, a leaky, cold building. And in Alaska, we all grow up around failed buildings. So that idea of how buildings fail in my climate led me to architecture. But I confess I didn't really think about the ethics or the social implications of it until I was midway through my process. Mostly it just was an idea of building physics. I was interested in creating buildings that fit our temperature, creating buildings that fit our climate. And there was a certain amount of indignation, I suppose, that started with that, the idea that our buildings didn't suit us. But it didn't last long into my career, and neither did the preoccupation with building physics. Next slide, please. And the reason for that was that after I started practicing architecture, I started working with some of our economically most depressed communities, our indigenous communities, and I realized that I had it pretty good, California high school or no. Alaska is in the middle of a deep and long-standing housing crisis. We have some of the worst overcrowding in the United States. We have some of the highest rates of respiratory infection in children and elders in the United States. It is a very difficult place to build buildings, and it's a very difficult place to survive in our buildings. Next slide, please. And so after working in these regions of Alaska, where a large percentage of people don't have access to simple plumbing, your toilet is just a bucket, where you have incredible amounts of overcrowding. Although I'm still interested in building physics, some of my indignation has died away. I had it pretty good. And also rising to accompanying an understanding of building physics is an understanding of occupancy and the types of people that inhabit buildings. And so the research side, while still exciting, has kind of morphed into an idea of architecture as community service, as opposed to just trying to solve physical problems. Next slide, please. So I was lucky to be picked up by the research center because the research center combines those two things in its mission. It's a group of very intelligent, very driven people that are interested in hygrothermal modeling of walls, are interested in foundation design on permafrost, but most of all, they're interested in people, because buildings are ultimately for people. And when we design for people, there are some interesting ethical questions that come up, which is exciting to me that this series exists, because I didn't start thinking about the ethics of design until I was midway through, like I said before. For most of the time that I've worked at the research center, I've been dealing with prototype home models. The idea that you could address a certain amount of building questions in different regions of the state by creating a prototype building and having real people live in it. So these 4 buildings are from 4 different regions of Alaska. And they started with the idea of asking different people how their buildings were failing them. Next slide. And when we take a step back and we talk about how buildings, it's hard sometimes for people to say, well, this is the building I want, but it's much easier to say, what's wrong with the buildings you have now? That starts a conversation fairly easily. And so we started projects with simple things like, on the top left, how can we use local wood to create log structures when our log structures are too cold and we need to figure out how to do a super insulated log wall? Or on the top right, how do we get away from long hallways that isolate family members and back to more traditional forms in plan? Or on the bottom left, traditional forms in elevation. How do we get back down into the ground like our traditional dwellings to be protected from the wind and the cold? However, to not go back to living in a prehistoric house, but having a modern house with that model. Or on the bottom right, how do we handle very rapid construction times, very short construction seasons to create more housing quickly? Next slide. And that kind of led to an idea that part of the reason that we were in the problem we're in is that there was a time when we thought one housing typology was going to serve all of an underrepresented area. And in Alaska, which is about 20% of the size of the entire rest of the United States combined, that if it were an independent country would be one of the 25 largest countries in the world, the idea that one housing type is going to be able to stretch across 4 climate zones and 14 different types of indigenous people and settler people in various states of assimilation is part of the reason we're in the problem we're in. Next slide. And so one of the things that is a part of our research methodology is to go to the places we intend to work with and to spend time on the ground talking about how buildings should work. And those raise some very interesting questions. Next slide. Some of them are architectural, some of them are engineering, and some of them are ethical. One of the questions that I found most interesting at the start of my my career was, you design a house and where does one butcher a seal in the house? Many of our coastal peoples depend on marine mammals for for sustenance, for subsistence. And one of the typical problems in early housing was that, you know, in the 40s and 50s and 60s, and even to today, was people would slaughter seal or whale, not necessarily whale, but seal in a bathtub area. The marine mammal waste would plug up the drain and the tub would stop functioning. There are a couple different approaches to the seal in the bathtub problem. One is the governmental approach, which has always been to just say, you know, don't do that. That's uncivilized. One is the engineering approach, which would say, I will design a drain that is robust enough to handle marine mammal waste. And one is the architectural approach, which would be to say, I will design a space with the occupant in the home that is designed specifically for butchering seal so that they will not need to do it in the bathtub. You might think that because I'm an architect, I'm trying to lead you to believe that that third solution is the best one, but really the engineering solution is just as good. The only thing that we need to get away from is the first, the governmental solution of saying, just let's change the occupant's behavior as opposed to design for the person that lives there. Next slide. Even if we're doing that, well, one of the things that kind of nags at the back of my mind is you're still designing as an outsider for other people. And not everyone, especially the poorest and most underserved people, can afford the risk of living in an experiment. And there's a long history of experimenting upon underserved people with our bright ideas. And so really, what we've done in addition to some of our rural work is we've gone from being, you know, half lab coats to half lab rats. I live in an experimental house on the campus of the University of Alaska Fairbanks. Next slide. And so does some other members of our design that worked on our design team. These houses are built as kind of a Punnett square where they have similar insulation values, similar volumes to heat. However, we can switch out mechanical systems as they come online, switch out ventilation systems as they come into the market. We have different foundations. We have some risky foundations because it is ethically easier to risk new design on oneself than on an underserved population. It's also right next door. My commute to work is about 200 yards. It takes me 4 minutes, and that includes the time it takes for my dog to go to the bathroom in the morning. So it's nice if you have a new system that's rather buggy and you can go check on it, as opposed to getting on a plane, going to a far off location where a family is already having difficulty getting by, and then, you know, testing your brilliant ideas on them. Next slide, please. So all that brings us, that's all background based on what we've been doing in our approach. I'm going to talk about 2 or 3 projects specifically where I try and talk about how these ideas of engineering and of the ethics behind engineering kind of come in together. One of my favorite things about architecture and design is you can steal things. You can steal ideas from other brilliant people. This is an idea that we stole from a South American country. There's an architect named Aravena. He works for Elemental Design. You should look him up. It's a pretty cool practice down in Chile. And one of the things they were doing was allowing, deciding that the most ethical way to represent underrepresented people is to give them the building blocks to represent themselves. And so this project in Chile is basically an infill project in an urban setting where a building was designed by an architect to have all of the essential services, but however, with space for the buildings to grow based on the occupants, so that the occupant was expected over time as they were able to amass modest financial resources to add onto their building, which was really exciting to us. next slide, but created some interesting building physics problems because most of the vast majority of Alaska is underlain by permanently frozen soils. Permafrost is difficult to build on. It's hell to add on to create an addition for. And so what we really needed to do was analyze how people were adding on to existing structures in rural Alaska and see if we couldn't provide for that in our initial design so that you could still create low-income housing or even housing for homeless individuals, but that as their means improved, they would be able to add on to their home and create a larger home. Two of the things that we saw most common in the top left, you can see an owner built what we call an Arctic entryway, a cold entryway where you have outdoor equipment, skins, things you wouldn't want inside like gasoline and other, chainsaws and things that should be outdoors, and also exterior stairs. Problem with Arctic entry design is, it's generally an add-on. It's not as well isolated, or the foundation is not as robust, and it moves it differentially in compared to the rest of the building. So in the sketch below on this slide, you can see what we're trying to do is create a large decking with an adjustable foundation on permafrost. Next slide, please. That could then be added on to as time goes on. So what you see here is basically a little tiny house for the village of Mountain Village, Alaska. It's about 400 square foot. For such a tiny house, it seems to have a pretty luxurious front terrace or deck, but next slide, please. The main goal is that deck could become a place where the occupant can build whatever they need onto the rest of the house, whether it be a large Arctic entry for subsistence resources. Next slide, please. Or even if it creates an additional third to the entire house with another bedroom and a larger entry. And then that way ceases to become a tiny house at all. The person can get into the housing to home ownership through a tiny house, but have a regular sized or a small house by the end of the process. Next slide, please. And the way we manage that is by creating a foundation that can be re-leveled by the occupant themselves. Next slide, please. So these are glorified inverted jacks. They're bridge jacks. And they allow the occupant of the house to re-level the house as it is needed. Our permafrost is changing rapidly. It is a difficult place to design foundations. It was a difficult place to design a foundation in my parents' time when the ground was permanently frozen. It's even more difficult today when the ground is behaving in very unpredictable ways. If you live in Charlottesville, you know deep in your heart that the default status of the earth is warm, that even in December, if you dug a shovel into the frozen ground, if you dug a hole deep enough, you would eventually get through the frozen ground to the thawed portion of the earth. In the Arctic, we know that the opposite is true, that the default status of the earth is frozen, and that even in the deepest summer, if we dug a shovel into the ground and we dug a deep enough hole, we would eventually come to frozen soil, which is the way the earth is supposed to be. And this is the easiest way to explain the difference between the Arctic view of the world and the temperate region view of the world. So our ground is starting to change, and that is every bit as catastrophic for our infrastructure and our foundation design as if in Charlottesville, everything under 18 inches, imagine where you live, imagine your house and all the services and water and sewer and electric lines and how deep your foundation is, and imagine what would happen to your house if 18 inches under the ground froze permanently over the course of your lifetime. And that's what's happening to us in the Arctic, is our world is turning upside down. It's very difficult for design. So we need, next slide please, small structures for residences that are able to weather that change, because the truth is none of the models agree. It's hard to predict what's going to happen to the subsurface thermal regime of our soils. So what we need to be able to do is adjust for it. And we need to be able to adjust without paying a company to do it. We should be able to do it ourselves. So these 6 houses in Mountain Village are kind of a look at that. Next slide, please. Another project that may seem interesting to some of you is the idea of a semi-modular housing model. Modular housing is it's a rapidly evolving field. It's an exciting field. Many people, and I'm one of them, think that great economic gains could be achieved through pre-building, prefabricating housing and sending it out to site. There are, for every answer you come up with in engineering or in architecture, though, there are ethical questions that follow it. And one of them is, if we solve a housing crisis by creating all of our houses and factories and send it out, do we exacerbate a job crisis? Because in a small, rural, remote, indigenous community on the coast of Alaska, where there is a housing crisis, there is also not a lot of jobs. And carpentry jobs, operator jobs, laborer jobs, those are good jobs. Those are jobs that could keep you off public assistance. And if we design a housing typology that goes to those communities at the expense of some of the only jobs in the community, then have we helped? That's a question. Next slide, please. And so in working with the community, what we tried to do was tease out the parts of construction that were A, very expensive, and B, not completed by people within the community. Those tended to be the electrical and plumbing trades. There's a lot of operators and carpenters and laborers in a typical small rural indigenous Alaskan community, but there's not often as many electricians and plumbers. So if you are a plumber, you fly out from one of our urban centers, you're making per diem, you're staying at a hotel, or if it's a small village, you're sleeping on a gym floor. At the school, it's costing a lot of money. If you've got all the parts there, then things can go pretty quick. If you're missing a part, then you sit there on per diem waiting for the part to fly out. And so what we tried to do was create a module that was just the electrical and plumbing portions of the house. So we fully furnished a bathroom, a kitchen, and a mechanical room. We put it in a container. We send it out. Next slide, please. We place that module on the foundation, and then the local crew builds the rest of the house around it with a warm envelope that can create a warm building. And what we've done there is tried to, just in a more surgical fashion, create architectural and engineering solutions, but then leave the rest to local people to do themselves. Next slide, please. The last project I'm going to talk about is one we've been involved with for 15 years, and that is the relocation of the community of NEWTOK, Alaska. NEWTOK has been facing advanced erosion due to the lack of sea ice and the melting of our permafrost soils. Next slide, please. And basically, our sea ice used to protect our coastline. Much of Western Alaska looks like Louisiana, but frozen. It's a bayou. It's organic. It doesn't have a whole lot of resiliency. However, the sea ice would kind of give us a free pass from the ocean. Now that the sea ice doesn't form as much as it used to, we're losing absolutely incredible amounts of shoreline. It's just falling into the sea. Next slide, please. In the time we've been working in NEWTOK, I've seen about 3 or 4 entire football fields of land fall into the ocean. I started working with the community when I was still in graduate school. I started my master's in 2005, and I had a really hard time convincing a committee to allow me to do a master's project on relocation related to climate change, because I had a hard time finding faculty members that believed it was actually happening, which is funny to think about now in 2022. But this model, which was created in 2002, that predicted the shoreline change over time, I would shop it around to professors to try and get a committee together for my master's, and they just didn't get much belief. Next slide. And this is 2022, and that model has played out pretty much exactly how it was predicted. And if you do live outside of the Arctic, that should catch your attention, because you're surrounded by media and by models of what's going to happen related to climate change in your region. And I can tell you, as an Arctic person, that they played out pretty much how the models predicted. We are in the shit that we thought we'd be in 20 years ago. And that is scary, but it also gives us a sense of urgency that I do not see as much the farther south I go. The Arctic has changed faster than much of the world, and what that means is I think people tend to be smartest when they have to be, and that's where good design can happen as well. So I think there's lots to be learned from our region about how we are handling relocations of whole communities. There are at least 8 right now on the list in Alaska that need to move in the next 20 years. NEWTOK is the first one that is relocating, but there are 2 others that are already in process since I started. Next slide, please. So what NEWTOK did was elected a new site on higher ground across the water. Next slide, please. And basically the first ethical dilemma is, well, how far up the hill safely should a new community be? Because the engineer in me, the architect in me says, well, they should be as high up the hill as we can get them. You know, that's the best place for an airstrip, the best place for a gravel quarry, for water. But if you take a people that have been living for 10,000 years on the sea, that all of their resources come from the sea, you can't take a group of fishermen from Maine and move them to Nebraska and feel like you've done a good job of preserving their culture and preserving their livelihood. You get them out of danger, but at what expense? Next slide, please. And so really from a planning perspective, you have to balance these engineering inputs, which is how to build a port, how to get gravel resources, how to build roads, how to get water, and you need to balance them with cultural resources, which is what's important for people. Where can they keep their way of life? How can they communicate to you as a designer what is most important to them? Next slide, please. So from the first site visit, where there was nothing out at the new Muktvik site, the research center, the lab, has created a relationship with the local tribal leadership where as things come up that they need, they can call the research center and get technical support. So next slide, please. We've gone from working with them on the construction of an evacuation center where they have a place to go if the old village eventually succumbs to the ocean. Next slide. We worked with them on the design of a home that could be built rapidly with local crew and train the local crew to build these rapidly erectable homes. Next slide, please. The first couple homes, or the first home, the first prototype, was built so that it could run off the grid. You could run it with a generator, knowing that the power, who knows when the power plant would come. It also was built on skids so that it could be built quickly before the town was laid out with new plats and before people had their allotments, and then towed to site. Next slide, please. Which is exactly what we did. We couldn't wait for the the platting of the new site, so we started building before the town site was platted, and then just towed the houses up the hill to their eventual site. Next slide, please. And tried to talk with the community about the indoor air quality, create a maintenance schedule in the indigenous language as opposed to in English, which for many people is a second language. Tried to get a school built there, which you want to see an ethical dilemma. How do you decide how many students are going to be a school in a town that doesn't exist yet? The state generally projects their student population based on a 5-year projection. And there's a reason for that. You can go to any village and anyone that is newborn to the age of 4.5 is going to be in school in the next 5 years. You can just count heads and decide that's how big a school needs to be for 5 years of growth. If people are leaving the community because it's falling into the ocean, then you can't count students. Half of the students in the NEWTOK school district have been displaced, have been moved to the city, and are just waiting to be able to move back to their traditional lands when the coast is clear. So from a policy standpoint, it's very difficult to plan for a school building. Next slide, please. So NEWTOK today, about half of the people are on the safe side of the water. About half of the people are still on the unsafe side of the water. Next slide, please. And once you invest in a new site, you stop investing anything in your old site. What that means is since 2005, there has been no investment in the old site. The dump went into the ocean, so there's no place to put their refuse. The sewage lagoon has been compromised, so there's no place to put their human waste. The power plant is very vulnerable. A number of houses have been destroyed. And so you're going to have, no matter what, an entire generation of people that lived in a town that was dying. And there's a lot of trauma associated with that, even when you do get to the safe side of the water. Design doesn't really have a good answer for that, how to address that trauma. Next slide, please. And none of this, very little of this, is covered in school by building physics, by the understanding of how R-value works or how foundations work. Technical research can make a move possible, but it's only a quarter of what you need. We need to understand our environment. We need to understand the cultures, both our own and if we're serving cultures other than our own, the cultures that we serve. And that takes a certain amount of sensitivity that you learn on the job that may not be taught in school. Next slide, please. So this is Mukhtavik, the new site today. The first year that we went out to build the first house, there was nothing here. And so there has been great progress. And on some days it's exciting and it's really rewarding. And on other days it's not, because we're out of time and only half the people are here. The other half are still on the wrong side of the water. So it's, in a lot of ways, we are still fighting kind of a losing war, which can be ethically heavy. I'll end here, and maybe we could talk, David, about some of these issues. But I hope that's been of interest to folks on the call. And I'm sorry if I went over time a little bit as well.
That was brilliant, Aaron. I was wondering whether I should cut you off, but I really wanted to hear the end of the story, so I let you go. Wow.
Well,
Thank you for these.
We'll have to wait about 10 years for the end of the story. We'll see. Yeah.
Right. Good point. Yeah. Thank you for these very concrete examples of making it so clear the issues that engineers and architects face, especially in vulnerable communities like this one. So let me just introduce David. David Gutierrez is a PhD student in civil engineering at UVA. His research aims to inform engineering and management through behavioral science to contribute to the solution of complex problems. He is interested in identifying and understanding how to overcome the social constraints for sustainable construction, and also in exploring the ethical dimension of sustainable development. David, we're so glad to have you. Over to you.
Thanks, Professor Wylie. Thank you for the opportunity to make part of this conversation. And thank you, Aaron, for an amazing and thought-provoking presentation. I do have a lot of notes here to ask you about, but I think I should start with what struck me the most. As I was telling you before, I am originally from Colombia. So many of the problems that you have just explained to us are pretty far from what I have experienced in my professional practice. However, I can say that the ethical quandaries that designers and builders face in Alaska and Colombia and in general in any other two territories of the world are tremendously alike. So from my perspective, ethics involves choices. And in my research right now focuses on how human values and sustainable design and construction means. So I can't avoid to notice tensions between these goals that as a designer you have. For example, you told us about how architects and engineering privileged user-centered design, whereas policymakers maybe privileged more behavioral change perspective in face of sustainability, maybe aiming for an improved affordability of housing. So I want to ask you, as a designer, how do you navigate this tension between these two values, between these two goals of affordability and user-centered design, maybe indoor space quality, which is very important in the circumpolar Arctic?
I'd say that's an important question. You know, when we, as Northern people, a lot of times we can't get past affordability because we can't even agree on what that means. You can build a very you can create a more affordable construction cost, and we could probably build twice as many houses per year as we're building in Muktvik, for instance. But we would do that at the expense of energy efficiency, at the expense of foundation stability, and at the expense of basically the thermal envelope. And so it is more likely that if we made that choice in the name of affordability, that once we left, the houses would not be affordable to heat by the occupant, that they would create an unseen burden on the occupants trying to feed them full of fuel. Same goes for poorly designed or quickly designed foundations, where if the permafrost would melt, then long after we're gone, or not that long after we're gone, the buildings would start to sink into the earth. So when we talk about affordability, we're often talking, and this is more common now, the sustainable architecture has more of a voice, is, are we talking about initial affordability, or are we talking about affordability of operation? Because those are not the same thing. And in underserved communities especially, we do a deep disservice by making affordable housing that you can't afford to heat. Now, when we talk about behavior, I think that is a larger question based on, you know, whose behavior are we talking about? How do different communities use space? Architects may be well trained to analyze spatial use, but you know, our internal biases always creep in. It's, as a human, we're always when we think about a building design that we're working on, we're thinking, well, how would I use this space? How would I do this? How would I? How do we design for people that aren't us? You know, that's the real question. How do, you know, if you're a custom home builder, then you can really get to know the family that you're working for. You can kind of get in their heads. How do you get in the head of another culture, another community, another tribe effectively? I mean, it takes a lot of time on the ground, spending time as an outsider, as a house guest in other people's regions and other people's traditional lands to get to the point where you're not daydreaming at night. I would do this. I would live this way. I would use this space. You're starting to be predictive. That's a hard. You're never going to get there. You know, it should make us uncomfortable to design for others in that way.
Yeah, I'm following on that. The construction companies and the design studios that usually work with you guys at the center, are they like like open to learn from their communities and the users from the northern communities? Because and not just about their habits and the use they make about these buildings, but also about their vernacular architecture practice and the way they have faced the challenging climate of the North. because let's face it, I mean, they have been there for literally thousands of years, and they have adapted pretty well to the constraints imposed by the cold environment. And to me, that speaks pretty loudly about their sustainability. So in your experience, are they interested in kind of adapting those indigenous knowledge to the current practices in design and construction?
Yeah, I'd say there's a segment of the population that is very interested in that. And there's a point in pride of being able to survive and thrive in a very difficult physical environment. And there's a generation of people that were made to feel self-conscious or ashamed of the way that was lived, before, that have their own journey with finding pride in the way that building physics problems were solved indigenously. It would be an oversimplification to say that all people in rural and underserved communities want to use a vernacular architecture. Sometimes the opposite is true. They want exactly what town has. They want their house to look like it does in the city. They want it to behave like it does in the city. While it is true that, in my experience anyway, indigenous communities in Alaska tend to be more consensus based than the urban communities in Alaska that I grew up in. We can't oversimplify and count on consensus as a given. Communities are going through changes. All of our communities are going through changes. The idea that you can get 600 people in a room and they're going to agree on what house they want is somewhat, I've found, to be a little naive. And so all the best we can do is let the leadership of the community make those difficult decisions, give them the tools they need to decide where they want to be on the spectrum between traditional, vernacular, and contemporary design, and focus on listening as not only to the consensus, but to any tensions that might be in the way of consensus. That gets pretty messy pretty quick, but it's where the fun design happens, right? It's
totally.
where good work gets done.
I think that it is possible to say that when you leave that choice to these community leaders, due to the diversity of these communities, some of the actors there can be like left behind in this decision, and their desires and maybe their needs regarding health, safety, and health are not really considered there. So what is, in your perspective, what is our role as designers regarding this community? How do we integrate their perspectives in the built environment we're planning?
I don't think I would have the same answer for that today as I did when I started my career. When I started my career, I think that, you would come into a community and you would have an idea that you wanted to test, whether it's returning to earth sheltered buildings or whether it's returning to, a floor plan in the round, and you'd find that right early adapter or that right local leader that would be a champion for that project. And the longer I go in my career, the more that I find it to be respectful to come to the table with as much technical knowledge as is possible, to be as sharp as possible with your building physics, so that you can just sit there and listen. And in that way, I think I'll always be in research, because there are, research is meant to ask questions. That's what research is supposed to do. That's where I want to be in my career, is asking questions. If you come with the answer, that's not really a research mentality, that's an inventor mentality. And inventors are just as important as researchers. It's half of the equation of what makes good design possible. But the longer I work, the less of an inventor I become, and the more of a technical assistant I become. And that makes me happier with my days, I think.
Yeah, And I think we're running out of time, but before...
Oh, David, you're on mute now, I'm afraid.
Yeah, can you hear me?
Yes.
Okay, so I think we're running out of time, but before we go, I would love to point to an idea that I really love about what you did and about what you presented in the second case. I really love the idea of doing what construction engineering management calls value management in support of a social goals. You know, when you isolated these plumbing and electrical systems that were done by people from other regions to protect local labor, that is great, because usually we do that, but aiming for an economic goal, which is lowering construction costs. So I really want to highlight that as an example of what we should do and how innovative we could be as project managers. And yeah, I wanted to congratulate you for that and for all your work you're doing with the center and with these communities. So thank you very much.
Thanks, David. And that project's still quite vulnerable because it's a one-off. It only matters if a private company wants to take over that bathroom kitchen design and say, I could make 20 of those. I could reduce the margins. I could put my profit in, and I could sell these. And if a private company doesn't do that, well, then where are we? Right? So we're still trying to plug these values into an economic engine somehow. It never goes away. We're never free of it. You know, and if that happens, then I'm going to be very happy. But if it doesn't, then we'll go back, start asking more questions.
Yeah, that hits on what you keep saying about balance, Aaron, that it's a balance between all of these factors, including capitalism. All right, so I want to share with you a couple of questions from the chat. Mostly they're about access. And this follows up on a lot of what David was asking, like, how do you approach a community and offer these services? Aaron, do they come to you? Do you go to them? Like,
Yeah.
how do you build these relationships to get this community-based research and listening started?
Well, this can either sound kind of lazy or kind of philosophical, but we don't approach anyone. We wait for the phone to ring. We don't have a marketing team. I'm the manager of business development at the research center now. It's a new role, but we are still primarily for these prototypes waiting to be contacted. And in a community as small as Alaska, we have less than 1 million people. Credibility is the long game. You know, every time a community or a tribe or a product producer reaches out to you, then you focus entirely, you give everything to that project and just count on the word getting out. If we did become more aggressive in looking for people to work with, we'd have to be much more careful because you're not looking for people to experiment on and to convert to your methodology. What you're hoping is that your work shows a level of thought and respect that people will come to you. Terrible business model, you know, but it's but I think it's, again, another reason that I like being in research because when you're in research and you're asking questions, people with important questions will come to you. I think that's you feel kind of blessed to be in research on those days.
Yeah, and the fact that it sounds like you learn a lot from them too. So it's not just a client relationship, it's really an exchange.
Yeah, I like to think that it's a public service more than anything else. Design as public service is a pretty wonderful type of design to be involved in.
It really is. Wow. And so do you see any role for the center in helping these communities get the attention of policymakers or communicating their needs to policymakers?
Well, certainly if you do have a product or an approach or a building assembly that works, you know, that being able to show that success because people in communities that are under represented and really backs against the wall from a climate change perspective need successes. They need to see that other tribes nearby are having successes. But then the other thing is when we ask our research questions, are the barriers building physics related, or are they not? Because a lot of times they're related to codes, they're related to sovereignty, they're related to culture, they're related to things that have nothing to do with building physics. And so then it does help to be the squeaky wheel and say, you know, we can't solve this moisture infiltration problem if we don't start enforcing building codes. We can't solve this problem if we don't start changing the way that private lenders traditionally exclude people living on off the road system or a subsistence lifestyle that you're never going to. How many people in this room could have bought their first home without a loan? And then imagine how many of people in rural and poor communities have no access to lending. You know, that's not a building physics problem, but it's one of the things that I think research should call out as much as possible, because it's not a level playing field in that way.
Yeah, I'll say, wow, the things we take for granted down here in the lower 48.
Well, and in urban Alaska too, in Fairbanks, I'm counting on a mortgage, and I'm counting on someone giving me a mortgage because I work for a national lab, but that's only one town. That's a pretty difficult type of privilege to deal with, you know.
Except that you live in an experimental house.
Yeah, that's true.
I love that aspect of it, that you guys your staff is putting yourselves out there as experimenters for these buildings. I think that's such a powerful way to remind us as designers that we are learning at the expense of others, you know, when we're enforcing our experiments on other people.
And it's humbling, you know, it's good to, when your own family's the peanut gallery. You know, when we designed this house, the team of us here at the research center, we were most concerned with the foundation, the permafrost, the mechanical systems, the access to natural light. My wife and I moved in the first day, and she said, I can tell a dude designed this kitchen. You know, had nothing to do with building physics. And so that kind of thick skin, you need that kind of thick skin, I think, to design for others.
And listen, yeah, to hear that feedback and maybe incorporate it for future projects.
That feedback's important. Yeah.
Brilliant. I think we're going to leave it there. I learned a ton today. I hope you guys did. I hope the audience did too. So thank you so much to Aaron, to David, to the OEC's director, Dr. Rosalind Byrne, and to our coordinator, Courtney Walker. It's been a pleasure.